All right, this is number 20. Let me read the problem. This is off additional unit 4 problems. Okay, you ready? This should be fairly routine at this point. Okay, let's try to stay ahead of me on the problem. Okay, try to stay ahead. It says a stagehand starts sliding a large piece of stage scenery originally at rest by pulling it horizontally with a force of 150 newtons. What is the coefficient of static friction between the stage floor and the 260 Newton piece of scenery? Okay, so let's do this. Let me just show you what static friction is as opposed to static friction here. Let's do this. Anybody have a calculator with little rubber feet? You know, like a TI, yeah, like that. Can I borrow that? Does that have little rubber feet on the back?
Like this? This?
Yeah, let me see if this works. Yeah, this is perfect. Yeah, this is perfect. Okay, so I want to show you what static friction is as opposed to kinetic friction. Okay? Here's a calculator. And you've experienced this before. Okay, little rubber feet on the bottom of it. And I'm going to push on it. And I'm going to continue to push on it slowly until it moves. There it goes, right? Yes, it's moving now, okay? Now, so once it starts moving though, it's easier to move. In other words, static friction is higher than kinetic friction. Like they call it, some books call it sliding friction. We don't call it sliding friction because we reserve the S for static friction. So I'm pushing, and then it gives way. Give me yours, give me the other one. This might be, yeah, this is even better. So I push, see, all of a sudden it goes, yeah? And once it goes, the coefficient of friction is less once it's sliding. It's that overcoming that inertia where the coefficient of sliding friction, coefficient of static friction is a little higher than the coefficient of kinetic friction. So you can say this as really, give that to Zeke, please. As really, you can say this as a rule. As a rule. You ready? The coefficient of static friction is always greater than the coefficient of kinetic friction. Kinetic friction means it's just moving. You know, like if I have this cart, right? If I have this cart, there's friction, right? It's like a sliding friction or kinetic friction. Get it? Yes, do you understand? So kinetic friction, so they're pulling the piece of scenery. It's probably a wooden frame with canvas on it, and they paint a scene. So they're pulling, all of a sudden it jerks free, and then they slide it. Correct? So that pulling on it is usually harder than once they get it going. And they just have to pull to overcome the kinetic friction. You with me? You understand, John? Makes sense? Okay. So we know that we know several things about this problem. One, horizontal. Right? It's horizontal. No ramp. Okay? Yes? we know two. The weight equals the normal force. They're equal, correct? Yes or no? Yes? Okay. We also know the equation. Coefficient of static friction equals the force of friction divided by the normal. Right? Now, let me reread the problem to actually give you the numbers. Okay? It says, a stagehand starts sliding a large piece of stage scenery originally at rest by pulling it horizontally with a force of 50 newtons. So they're pulling it horizontally with 50 newtons. So what's the friction? The force of friction equals 150 newtons. Correct? Yes? And then it says, what is the coefficient of static friction between the stage floor and the 260 Newton piece of scenery? So they're saying that Fw equals 260 newtons, correct? Therefore, we know that Fn equals 260 newtons because of this, because it's horizontal. Therefore, we can say this. Mu equals force of friction over normal, correct? Yes? And we can say 150 newtons divided by 260. And what is 150 divided by 260? What is 100? All these fancy calculators. Do you know that that calculator has more calculating ability than the computer that aided the astronauts on July 20th, 1969 to land on the moon? And she's ignoring me. What she's doing, she's giving me the answer. She's ignoring that incredible piece of historic information. Thank you, Zaytun. What did you say, hon? 0.6? Okay. And let me ask you a question, Zaytun. What are the unit labels for that?
Nothing.
There are none. And I'm going to put a blank space next to it, and if you put anything in that blank space, it's wrong. Understood? There are no unit labels for, and why aren't there unit labels? Because of this. Unit labels cancel, we are off.